I'll start recording now. Okay, so the the website is hybridplc.org, and that's my website. That's a private web. That's my own website. Hybrid PLC, mechatronics, and that type of thing. Now here is the courses that I've taught or teach, and you come down here to EECS 4220, and that's where the syllabus is. And there's where that is. So again, I've got the lab names numbered correctly now on this screen. So this one is right, yours is wrong. So you can copy these off if you want to. Any questions about that? I'll get my little pen over to the side so I can describe things as I go. I did not, on this syllabus, put my phone number, although it is common knowledge what it is and most people know it, but I'll give it to you. Okay, so my phone number of my cell phone is 419-343-3681. And that gets me. If you want to know how to track me down, that's how to track me down, okay? The rooms over here, 2350, has a keypad. It's 4575 #. That gets you into that room. Now, 1100 is that one of the robots downstairs, okay? And that one, you will have a keypad access, you'll have a key access to that one. And 2390 will have also your rocket card access to that one. So you have a card swipe, keypad, card swipe access, okay? The text for this is here under home, under hybrid text, and there are two texts. One is, can everybody hear me? Am I coming through okay? Good. Okay, so one of them is the text that we're going to use, and everything is referenced out of this. And I wrote all this. We're going to go through chapter 1 tonight. And it's a fluid text in the sense that, I did have it at one time published, but then I took it off because you can't get anybody to publish this text. Simple reason, Alan Bradley won't support it because it's got Siemens in it. Siemens won't support it because it's got Alan Bradley in it. And nobody's going to put their dime with it. And that basically is what a publisher needs. They need to have somebody supporting it or behind it. Who's going to do that? Nobody. So basically it's just, I said, okay, it's just going to be a free text. At one time I was going to charge for it, and I did a little bit, but no, it's free. It's yours. Now, is this of any value? Is this a good text or not? You decide. There's a lot of stuff here. There's a lot of chapters with 100 pages in them, and sometimes it's messy. Sometimes it's really good. It's a little dated in some ways. There's historical layers here because the software has changed over the years, and you can see some of that in this. There's some year 2000 stuff, there's some year 2010 stuff, there's 2020 stuff, and there's some 2025 stuff, and it's everything in between, okay? So we're going to go through chapter 1 tonight, okay? So that's that. Now, if you are interested in the Rubik's Cup thing, I got to get back to this. Rubik's Club, high school Rubik's. Okay, so this is a bunch of videos, okay? and then a book right here, text accompanying the weekly projects. And at the end of this book, it's 102, 103 pages. The last 3 or 4 pages of that is my clues on how to write the program to solve it. So you can look at that and see if it's something that you want to tackle or not, and that's up to you. If that's something that challenges you, go for it. Now, these videos right here are for the high schoolers, but you can use them as well. If you want to know how to solve the problem at the end of chapter 13 on how to write the program for the Simon Says program, which is a chapter 13 program, it's done right here for you, exact. So I do things for them that I wouldn't do for you because they're high schoolers and you're college students and you need to be challenged. But anyway, I do some things for them, but it's basically the same stuff. I go through theirs kind of simple, but yet with the hopes that some of it catches on and they get through some of this. So this is the high school stuff. Okay. And then the blog, I have not any idea whether the blog's ever going to work or not. And here's our courses. And then there is a second book on just labs. And these are labs that work with PLCs. They also work with Arduinos. They also work with Raspberry Pi, that type of thing. And they are an outcropping of the text, but the text has got too big and sloppy to have all these labs in, although some of the labs appear in both places. So don't be confused. Well, it's over here and it's over here. It's the same lab. Yes, I know. But I tried to incorporate as many labs as possible, okay? Also, under courses, there's a course called EET 4450, which is automatic controls, which also has some PLC labs, and it talks about PID in it, and there are some labs there as well. So, and it also includes the vision. So again, when I talk about various topics, some of it I just no more do I want to duplicate my effort and put it everywhere. So you've got in the 4450 class from automatic controls, you have PID as well as vision. Okay, so that's happy hunting. How's that? It's in various places. Various things are in various places. Okay, so let's go back to this. This is chapter 1, and this is kind of interesting because this happened right at the time that I was graduating from college, and I had no idea about it until I walked out in the industry, and then hey, they had this thing called a PLC on the wall, and up until then, everything was big fat cabinets with relays. And these are big, big, big relays. And you say, what's a relay? Well, you're going to learn that in chapter 2 because you're going to do that lab because that's the only lab that is required. And it's 2.1, and I'll explain it to you on Wednesday. But that lab is a required 2-point lab. So everybody's going to get that one, unless you've done it before, everybody's going to do that lab. Why? Because where did these things come from? PLCs. They came from simulation of logic that was done in panels prior to computers, and the basic building block was relays. And if you don't understand what a relay is, it makes it very hard to understand why we simulate them with a PLC. And that's kind of how ladder logic got started, and that's how ladder logic exists. So again, you don't have to be an expert at it, but until you get in your head that for instance, and this takes some time. That's not a capacitor, that's a contact. Huh? That looks like a capacitor to me, doesn't it to you? It's not. That's a bit. It's either a 1 or a 0. It's either on or off. It either passes power or doesn't pass power. So again, it's just the little subtle things that we'll talk about. And once you've done that lab, they're cemented in. You'll never forget them. And that lab, once you wire stuff up and use your hands and do that, it kind of is, it gets ground in. So that's why we do that lab, okay? So anyway, so back in the 1800s, Why did they even call it a relay? Well, because up until they invented relays, there would be a telegraph guy, and then he would go 20 miles, and then he would have to repeat. You'd hear the signal, all that kind of stuff, and then he would have to type it again. And then another 20 miles down the road, there would be another guy be typing it again, and then they would be typing it again, and they'd be typing it again. So somebody came up with this idea that we'll have a battery, and we'll have this relay, it's in there, and then it'll automatically, you can go 20 miles, and then the thing will automatically transmit another 20 miles and transmit another 20 miles. That's called a relay, and that's why they use them as relays. But they also discovered that they were good for logic, Boolean logic. Here comes the train down the track, okay? You want to have the gate go down. So it trips on the one side, and it says go down, and then the gate goes down. And then when it goes by the other side, gate goes back up. Okay? Simple logic, but again, to protect people from going across railroad tracks, they put that logic together, and it made good sense. And it worked its way into automation and factories. So you'd use relays to do simple and then more complicated and more complicated and more complicated logic in factories. And by the time I got out of college, I walked into Libyon's Ford, and on the walls of their lines where they make glass, they made flat glass, you would see these big, massive panels. And they would click, 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 all that kind of stuff. That's big old fat relays that were in there, and they were basically doing all the sequential logic to move the pieces of glass down the line sequentially, logically, so that you could control the flow of the glass on the line. Okay? Same thing with automotive, same thing with anything else. They basically built sequential machines using relays. And that's how a lot of automation is done, is sequential things, okay? So that was done. And then along came the automotive industry and said, computers are getting more sophisticated, and we are really tired of having to, every auto changeover, having to rewire all these panels. Can you imagine 3 weeks or 4 weeks in the summer every year when they did an auto changeover, a model changeover, they had to strip away some of the wiring in a panel or the whole panel, move in new panels, do this, and it was hard. They would say, we would like to simplify that process if we can, okay? And that's what pushed this. And it was not someplace up in, it wasn't at Caltech, it wasn't at MIT, it was at Ypsilanti, Michigan, of all places. They wrote a specification, and then, of course, they had an argument. Who's going to win, right? Always. There was the IT people, and there was the controls people, and they went at it. And they both basically wanted their product to win, and thank goodness the controls guys won, because it's a very practical program controller that evolved from this. And the very first program controller that came out of this thing was basically nothing more than a bunch of if-then-else statements. That's all it was. And if you don't believe me, we get into chapter 3 and we talk about that first one and the logic of it, and it's just a bunch of if-then-else statements. What is it about an if-then-else statement? If-then-else statements. What is it about it? Can't be bombed out. You can't lose control of the flow with if-then-else statements. You won't lose the program counter. You won't lose where you're at. If everything is an if-then-else statement, you just keep click, 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 click down to the bottom. And then when you get down to the bottom, you write your outputs, you start from the top again and keep doing it. Just keep doing it. Okay? Brilliant idea. And that's what it was. That's what a program controller was. It was a simulation of a relay using nothing more than if-then-else statements. So now you know the basics of this, okay? And by the way, they cost a lot of money. If you wanted to know in Detroit how to spot a Modicon program controller salesman, look for the Mercedes-Benz. They were the guys driving the Benz. They were, the big money in that era. And a PLC would cost $50,000. Easy. Just one PLC would cost $50,000. And, and they justified it because it was better than what they had been replacing it. Okay. And the guy that did all this stuff, the inventor of the PLC, is a guy named Dick Morley, and he was kind of he was a good guy, really. I never met him, but I you know, he's a anyway, kind of a jokester, but he was a very good guy. And he came up with this idea, and he basically doesn't take credit for it. He says, it's just an idea that came along. Now, the people that he was at MIT, he didn't work at MIT. He had been a student at MIT and then quit. And then he was an engineer at this company in Andover, Massachusetts, called Bedford and Associates. And they were the ones that won. And they called their programmable controller the Modular Industrial Controller, or MODICON. MODICON is Modular Industrial Controller. That's what it's short for, okay? And it was an 084, MODICON 084. It was their 84th project that year. That's how the 84 came about. Anyway, they won, and they were the ones that started selling the biggest amount. Then Allen Bradley came along, and by the way, they wrote a specification, and they basically answered the specification, and I've got all that stuff in the book. It shows you where it's at and all that kind of stuff. But Allen Bradley came from a startup company in Ann Arbor that was working on the same thing, didn't get to the final thrust. They didn't get to the final stage. They weren't one of the finalists. But Allen Bradley bought them, moved them to Cleveland, and they become the Allen Bradley PLC version, or that's where they started out. Okay. There's the specification. This is all stuff that it's live. I mean, this happened 55 years ago, but it happened in this area. This is not something that was invented in Germany or someplace else. Now, the Germans were doing stuff themselves, but this is stuff that was invented right here in the Midwest. There's the specification sheet, who was the winner and all that kind of stuff. And there was the first programmable controller programmer. This is the first physical programming panel to program a PLC. That was the MODICON 084 programming panel. I've used one of these, and I guarantee you that the only thing you get out of this is not blisters, but calluses on your fingers, because everything is done with thumb switches, and then you hit a button to set you set an address with a thumb switch, and then you push the button to accept it. How did they save the programs? They didn't have tape drives. I've done this as well. They had a modem that went to a phone. And so you plugged in the modem to the phone, and you had to have a phone in your control room. And you would call Andover, and they would tape your program and store it on a computer there in Andover, Massachusetts. And you would call them up and say, I am so-and-so with such and such a program. You give them the serial number of your program controller. And they would say, are you ready to go to dater? Yeah, I'm ready to go to dater. So you'd slap the phone down on the earpiece, and then when the light changed from red to green, you know that they were done. That's how you went to dater, and that's how you saved your program. Anyway. You don't have to do that anymore. All you have to do is hit save, and it saves it onto your hard drive. And it's too much. But anyway. Okay, so this is some of the evolutionary words that we went through in the Siemens as well. I want to get down here to, can everybody see this okay? Is it good size for you? Can everybody read that? Okay. Okay, I want to get down here to, I want to show you how things evolved. Okay, so this is in the 80s, the early 80s. Who was on top? Who was the winner? Who's the big boy? Well, Allen Bradley. They were the number one. Who had bought MODICON at that point? This was Siemens. They were number 3, and everything. The other brothers were the biggest, though. There's a lot of competitors in that era. Okay, that was in 1982. What happened in the next 10 years? Oh my goodness, what happened? Siemens became number one. Allen Bradley stayed pretty good, and then things settled out, didn't they? Modicon was then bought by AEG, and they're way over here. They're a little bitty slice. So you have the world order the way it's pretty much been ever since. Siemens, then Allen Bradley, then the two Japanese companies, and then everybody else. You still have Modicon, but they're not nearly as prevalent as they were. 2007 and 8, even more. And the last one that I got in 18 was right there. Now, what happened in that era? Well, first of all, I put numbers on them, didn't I? But also, I got some of the stuff that I don't know where I got all this stuff. But anyway, what happened in 18? ABB came online. So ABB is small, but they're a competitor now. And ABB is worldwide is a huge company. So who's the biggest company in electrical and electrical controls in the world? Siemens. Who's the next biggest? ABB. ABB is big in robotics, but they do not have hardly any PLC brand at all. But anyway, it's not that was interesting. This is a quote. So I was asked to write a book for Siemens, and they sent me this box with all this stuff in it, and then they sent me some books to write from that I could copy or do whatever with. What do they say here? Easily programmed by skilled workers, that type of thing. Okay, here's the part that I want you to read. Okay. Siemens used STL, which is like an assembly level programming language. Okay, so if you like to write an assembler, that's what they used. It seemed reasonable to program something the way people like to think of it and describe it verbally. High education standards in Germany and Europe also supported this approach. Now, what's this statement right here saying? Everybody read it? I mean, is it too low? What does that statement say? Ouch. That's what the Siemens think of us. Yeah. So one of my challenges to you is outdo them. Okay? Be good at both Allen Bradley and Siemens. Learn both of them, and then just tell them, okay, smile at them as you go right by them. All right? I know that we have problems in the United States, but daggone it, we don't need to be reminded of them, and we need to work to basically alleviate them. And that's what I want to do, at least as much as possible. Now, I want to show you something else back here. This is a picture of the people in Germany, okay, in 08. This is who was in that picture in Germany. Now, who do you think? I didn't go. I wasn't there that day. I took my wife with me. I was a little bit of a coward of going over there by myself, so I talked her into going. I said, we could have a vacation as well as me going to school. It's a bad idea because she was stuck in a hotel a lot. But on the other hand, that was one of the last days, and I skipped it, and we went on a little tour that day. But who are the people that are there in Germany learning about Siemens? Well, I'll give you a clue. There are about 40 people, and 19 of them were from China. 7 of them were from Mexico and South America. My lab partner was from Colombia. And there were 4 of us from the United States, and 7 from Eastern Europe, and Russia and Ukraine, mostly from Ukraine, and then 1 guy from Turkey, 1 guy from Malaysia, nobody from Japan, nobody from Korea, 4 from the United States. Now, who were they from the United States? There was a salesman, and then 2 guys who were working on, they had to support Siemens, who was moving a plant in a Mercedes-Benz plant, and the Mercedes-Benz people required that they teach Siemens because nobody knew Siemens in the area that they were going into, Spartanburg, South Carolina. So they had two guys that were learning Siemens to support that at their junior college level, and myself. I was the only person there, just like, show me all you got, you know, and I just basically like a sponge. What does that say? It doesn't say I'm a hero. It says I was willing to put my foot in the water and my toe in the water, but there were 19 from China. Okay? They wanted to learn this stuff, and they wanted to learn it well. And, you know, I tried my best every time they did a lab to be the first one to get the thing done. You hear the ball drop or whatever. I never was. They were very good at programming as well as teaching. So again, I just want you to see the world. Picture of what's the people that are in the world. And not that we're not as good as them, but I want you to see the competitive nature of the world, because the world is competitive. All right? It is. So it's not to put you down, not to put us down. It's just, this is us, okay? And then every once in a while I put in something just for fun. So, not a big deal, but just something to say. Are you still awake? So, all right. So again, did I not answer anybody's questions? Anybody have any wonderments as to what's going on? Yes, sir.
For the labs, so we don't have to do all of it except there's 20 points worth according to the so
It's like there's 40 points worth.
40 points.
There's
So we have,
2-point labs and 4-point labs.
is there a minimum requirement of Siemens?
No, but the only requirement that I have is that you have to do 2.1, and also that you have oh, and by the way, this list isn't complete. This is from when I stopped teaching in 23. That's where we ended in 23, and I've basically not added in anything, very little to it. But you have to do 20 points by April 1. So I don't want a big dump of programming points after that. And you can't, there are some labs where I also have there are some other labs that are in the lab book that are not on this list, and I will not accept them. Okay, they've got to be off, those first ones especially, they've got to be off this list. So if you come in and you say I've got a lab from the lab book as opposed to the text, it's not on this list, I won't accept it. There's a whole bunch of labs in there. They're just kind of like, there's a bunch of them, and I do not, and also you can't, I don't say this, but you can't do a lab, Allen Bradley, then do the same lab. Okay, you can't do a lab wired Allen Bradley, then wired Siemens, and go back and then do it, instead of with the wired, do it with the HMI, and then do it with the, you can double dip, but you can't 4-dip, okay? You can't do the same lab 4 times. You can do it twice, but I will not let you do it 4 times. I don't say that in here, but you cannot do it 4 times. But in this process, if you look at the way that I've done this, and I'll try to describe it better later. The labs can be done more quickly if you use the HMI, the screen that you can play on your computer. In other words, I can have an operator panel, control panel with buttons on it, on my computer and run off of that as opposed to having to wire a lab. And it goes faster, and you can get the same points that way as you can by wiring a lab. So you may want to wire a lab or two, just, and you have to wire lab 2.1, but you may want to wire a lab or two just to get the idea in your head how to wire them. But after a while, you're probably going to say, in order to move faster, I'll not wire the lab. I will, some of the labs have to be wired. There's some of them you just have to wire. But some of them, you can go either from a wired system or you can do it from a HMI. And if you look at the labs on the Rubik's project, that's the attitude that I took. In other words, I went through 3 labs and I did 3 labs. And if you look at the Rubik's Cube labs, they're your same labs. I mean, you can look at the labs here, the 4.1 lab, the hot dog counter. Look at the Rubik's Cube lab, because it's the same lab. Okay, so I went through and I did it, and then I did it again. Also, in the COVID era, I didn't know if I was ever going to teach live again. So I went through and did all the chapters as broad as I could. In other words, a chapter has a 2-hour lecture to it, which is much more broad than you're going to get here. So if some of them go 2.5 hours, but if you want a more definitive how things work, if you want to know how it goes with Alan Bradley, how it goes with scenes and all that kind of stuff, it's there. I mean, those videos, some of them go forever. I'm not suggesting that you do that because you don't have time. But the videos on the chapters that are on the website are there, and they're massive. So I didn't really know if I was going to ever teach live again, so I did everything I taped. Now I'm taping it again here because we're jumping around. We're not going through everything as, you know, I hit the high spot. I hit some of the high spots because this course is really 2 courses. It's for EET students, it's 2410 and 4550. It's 2 courses. And it really, to soak it up, you really do need 2 courses. Unfortunately for you, you only got 1. But to get an idea, you know, I just hit the high spots. But it really is 2 courses. All right? Any other questions? You might, what the heck is this about? It's like, it's a lot. But you get a good idea, and there's nothing in here that you can't get. Like I say, 5 to 10 years of working in industry, you'll get this and more. But this gets you a starting point. Toe hold, if it's something you don't like to do, you'll know it. If it's something you like to do, you'll know it. I've had a few, not many, but a few people say, thank you, I appreciate this, I never want to do this the rest of my life. And you know something? If that's, I hope it wasn't me, I don't think it was. They say, no, it's not you, it's just, I don't like doing this. Some people like doing this. And you'll know after a while whether you like doing it or not. And you'll figure out a way, if you don't like it, to get through the course. I don't funk you. But again, I will make it challenging, but not to the point of taking you over the edge. But on the other hand, you'll learn a lot because it's how to attack. Okay? I promise you, you'll learn how to attack different projects and different problems with this stuff, and you'll know more than you did when you started. I think it's okay in here, as far as I'm concerned. I'm a little bit more used to it now. I did this the first night, or the first live show, like, what on earth? But I think after being in here just a little bit, I think I can exist like this, and I'm going to do it more from over there. You're not going to use your computers for me in here. These computers do not have the software on it. The software is in those 3 rooms. And we're moving to, if you want to know specifics, we're moving to version 20 of Siemens this semester. And we're going to stay with version 32 or 33 in Allen Bradley. So if you want to know versions of the software, we're staying with what we got in Allen Bradley, we're moving to 20 of the Siemens. And as a result, the videos that are in the, and I'll explain it to you where they're different. The old stuff, the old version of the Siemens, there's a caveat. I'll explain it to you. They're there. And you gotta understand that they've made changes to the software. All right, any other questions anybody's got? I think I'm gonna say, dismiss you and say, we'll see you on Wednesday. Take care.